part III discuss about the difference and complement of two sets. Coming back to example about class 10 is, suppose set A containing the talented students in class 10E. Set A include and set B containing the students in group 1, class 10E is set B contain. Determine set C containing the talented students in class 10E who do not belong to group 1. It's easy to determine set C contains so they are students in set C, so which is MØNH is the elements of set A, but not the elements of set B. Similarly, Cường, Bảo, Hoa, and Lang. To create set C, we choose elements which are in set A, but are not in set B. Now example, set B contain 1, 2, 3, 4, and 5, etc. And set E contains 1, 2, 3, 4, 5, 6, 7 curly brackets. If I call F E the set difference of D and E, so set F contains elements that are in set D but not in set E. So F have to contain 6, 7, okay? And the concept of this kind of sets, set C containing elements in set A but not in set B equal the set difference of A and D. C is the difference sets of A and D, and this operations denote C equal A, B. You know, this simple equal sets minus, or we can denote these operations by C equal A minus B. And this Venn diagram shows set C, which is the area with the diagonal lines. You see, this is set A, this is set B, and this is set C. A minus B contains X, so that X is an element of A and X is not an element of B, or X is an element of the set difference of A and B if and only if X is an element of A and X is not an element of set B. So this is a way to express the set difference between two sets. There is a particular case when B is a subset of A, then set difference of set A and B equal the complement of set B in set A, denoted by C A B. That means complements of set B in set A. And the Venn diagram, you see, this is set A, the big one, and this set B, the small one, and set B is a subset of set A. So the diagonal lines E the complement sets. In this example, F is the complement set of D in F because D is a subset of set E. You see, D is a subset of E. Then F equal C D. That means F is the complement set of set D in set A. We have already finished the theory parts. Next, we consider the exercise to help you to get a deeper understanding. After learning theories, you should apply them to do exercise to know what level can you understand the lessons. And there are 4 problems of this session. I'll help you to solve some, and you should finish the reminder. The first problem. Symbol A is the set of the letters in the saying where there's a will, there's a way, and B is the set of the letters in the saying practice makes perfect. Determine A intersects B, A union B, A minus B, and B minus A. Firstly, we have to determine which letters are the elements of set A and set B. So this is set A contain letter W, H, E, R, T, S, A, I, L, and Y. Remembering that we should write a letter only one time, and set B contain P, R, A, C, T, I, E, M, K, S, and F. If I call C is the set intersections of sets A and B, that means C contains elements that are in set A and in set B at the same time. Then it's denoted C is equal to A intersects B, and C contains E, R, T, S, A, and I. Because we see the element E is the elements of set A, and E is also an element of set B. Similarly, R, T, S, A, and I. Next, if D is the union set of sets A and sets B, that means D contains elements are in set A or set B. Okay, this is set D. D equal A union B. So D contains the whole letter up to sets D equal, you see, W, H, E, R, T, etc. You can name it. Keep in your mind, don't write one letter twice. That means, you see, element E is in set A and element E is also in set B, but we just write one term in their union set. Okay. And the last, the different sets requires us to find the elements which are in this set but are not in other sets. So if I call E is the set difference of A and B, or E equal A minus B, that means E contains element in A but not in B. Do you know which elements are contained in E? The result is E contains, you see, W, H, L, and Y. Okay, because you see, W is the elements of set A, but it is not an element of set B. So W is an element of set E. Similarly to H, L, and Y. In opposites, F is the set difference of B and A. So F has to contain elements in B but not in A. F equal B minus A. F equal P, C, M, K, and F. You see, the element P is in the set B, but is not in the set A. Similarly, the rest of the elements.